So we've been graphing equations where we've changed the amplitude and the period. Now we're going to graph equations where we change the amplitude, the period, the horizontal shift, and the vertical shift. And that's what we're going to be doing today, is putting all these together. So I want to just review really quickly amplitude. I think you guys all know what amplitude is, right? Yeah, I think you know that one. Okay, A equals amplitude. Struggling with that today. Amplitude. Okay, we all know what K does. What does K do? Well, yeah, it has to do with period, doesn't it? It affects the period. Okay, K is basically how many times, like you were saying, Mitchell, how many times, well, how many cycles, I should say, how many cycles take place from 0 to 2 pi, from 0 to 2 pi. Okay, that's what it does. And we learned a formula for period. What was that formula?
2 pi over k.
Yeah. You will want that on your 3x5 card for your next test. Okay, and we've talked about how to change the period and so forth with K. So now we're adding to that C. And C has to do with this formula right here, phase shift. PS stands for, I'm going to call it phase shift. And the formula is phase shift equals C over K. Phase shift is how much it shifts left and right. It's the horizontal shift. And then we have H is the vertical shift. I don't know. So, we're going to do a few, I'm going to remind you of the amplitude and K, how that will affect the graph. And then I will teach you about phase shift, and then we'll add to that the vertical shift. And then we're going to put it all together. And we are going to give you some problems where you have all 4 things taking place, and you have to be able to graph that by hand. Okay? Put the calculators away. In fact, we're going to put the calculators away in all of these. Okay, so I want to start with, are we done writing that down? Okay, we are going to start with, well, before I do that, we're going to start right here. And let's say I give you y equals -3 sine of 2 theta. Remember, theta and x are the same thing. They're just the variable. They're the independent variable. Yeah, if you want to put an x in there, that's fine. So we want to graph this thing, but before we can do that, we need to know what the period is. What is the period?
2 pi over 2.
Okay, yeah, we use the formula 2 pi over k, and what is k? 2, so we have 2 pi over 2. What happens? Okay, and we end up with pi. So the period is pi. Well, what does that mean? That means oh, and by the way, since this is a sine function and the amplitude's -3, where am I going to start with, and which direction am I going to go first? Okay, start at 0, 0, yep. And I'm going to be going down since it's a negative amplitude, right? So normally this function, I'm going to mark these right here and about right here. Normally the sine function goes, if a negative sine function would do this, right? But we changed the period. So what's going to happen is we are going to have one cycle, instead of one cycle taking place between 0 and 2 pi, one cycle will take place between 0 and pi, right? Didn't quite go down far enough, right there. And then we're going to have another cycle take place right here. In other words, k tells how many cycles take place between 0 and 2 pi. And so you can see we had 2 cycles between 0 and 2 pi, or a period took pi units to complete. Any questions? Do you remember that? From last time, I think you guys had that down pretty good. So what we are going to do now is I'm going to give you a couple of problems where we are going to find the phase shift. And we're going to start with this example right here. Sine of theta plus pi. Y equals sine of theta plus pi. Y equals sine of theta plus pi. And we want to, first of all, we need to know the phase shift. Okay, so what is the phase shift? How do we get it? C over K. So phase shift equals C over K. Well, what is C and what is K? Is C pi? It's actually, C is going to be negative pi.
Negative pi.
Yeah, C affects the phase shift. C affects the horizontal shift. It's one of the numbers that affects the shift. Okay? And so let me go back to right here. C is this number right here. Okay? And K is this number right here. Right here. So if you're looking at this right here, okay, notice that this is a minus sign right here. So back on that problem that we're working on right here, back on this problem, this is really saying theta minus a negative pi. Do you guys see that? Because it's supposed to be a minus sign there. So that's why I said C was a negative pi. What is K?
If it's going to be plus, it's always going to be.
Yeah, in other words, just take the opposite of whatever the sign is right there. As long as there's not 2 signs. Okay, if there's 2 signs, then you take the one that's next to it. Okay, so negative pi divided by, what's K? Yeah, it's just 1. So negative pi is my phase shift. So I'm going to shift this thing to the, which direction? To the left, pi units. Because right up here, it's the opposite of that. But it's going to be, actually, you got negative pi, so it's going to shift it negative pi. So I'm going to mark this on the graph right here. I have, we're gonna go every red line right here. And so I'm gonna go out to that, and that's gonna be pi, right? That'll be pi right there, and that's gonna be 2 pi right there. So this is pi halves. This is 3 pi halves. And we can mark it in the other direction. So we have negative pi right here. Let's see, 1, 2. Negative pi here. And negative 2 pi right over here, right? So this would be negative pi halves. This would be negative 3 pi halves. So we know, we're going to graph both functions, the regular function and the new function. Now keep in mind that the period of this is, or the amplitude of this is what, everybody? Okay, 1. So we're going to graph this regular sine function first of all. Here's the regular sine function. Goes up like this. through pi, down to 3 pi halves, it bottoms out, back up here, right? If I did it the other way, it's going like this, this. Okay, but with the phase shift, we are going to phase shift it pi units left. Well, I'm going to take this point right here, you guys, where it's crossing the y-axis. And I'm going to move it pi units to the left. That's to right here, right? So it's going to go up right here, down right here, up right here, down right here, and to there. So it's just going the opposite of the other one, right? Okay, so the blue one is the graph of y equals sine of theta plus pi. We shifted it. We moved it to the left. Pi units. Let me show you this way. Let me grab. I didn't keep a continuous graph right there, or it would have worked. But if I was able to drag that green one to the left, pi units, I'll just grab this part right here. If I was to move it pi units to the left, there's where it would be, right? Right on top of that one. So, but I didn't do it as a continuous graph like I should have. Okay, that's a phase shift that way. Let's do the next one. Let's give you this one. Y equals cosine of 2 theta minus pi halves. Y equals cosine of 2 theta minus pi halves. Okay, find. I'll give you a second, you guys. I'm going to see if you guys can graph this one. Find the phase shift, and then let's graph it. Talk about this. Plus h. Well, we're not doing, that's a vertical shift, and we're not doing the vertical shift yet. We'll work on that in a second. Okay, the phase shift is equal to c over k. What is c and what's k? Pi half to c over 2, which is k. Well, how do you simplify pi halves divided by 2? Yeah, think of the bottom number 2 being 2 over 1. Remember, you guys, to simplify a fraction, flip that over. So pi times 1 is pi, 2 times 2 is 4. So your phase shift is 4 units. We are going to shift this 4 units. Any questions? Okay, so this one right here, so this one right here is a cosine function, so we know, and the amplitude's 1, so we're going to start right up here at 1, and let's go again the same scale that we had. Okay, there's 1, 2, negative 1, negative 2, and here's pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, and 3 pi halves, and 2 pi. Negative pi halves, or negative pi halves right here. Thank you. Oh, I just erased that and I did it again. You know what? I am having, I'll admit, I'm having problems today.
Me too. We should just go do
Okay. Okay, so I'm going to graph just the regular cosine function first. Regular cosine function starts right here. Right here at 0, 1, right? It's going to bottom out right here at pi. It's going to cross at pi halves, bottom out, come back up, and end right there. That's the regular cosine function.
You gotta move it over pi.
But we are going to move it. We are going to shift it pi fourths in which direction? Oh, we had a period change too. Remember, we had a period change.
It's pi.
What is our period change? T equals pi, right? Because 2 pi divided by 2 is going to be pi. So we're going to have one cycle take place between 0 and 2 pi. So my new function looks like this. Had two functions take place between 0 and 2 pi, right? Now, I got to take this red one, and I have got to shift it pi force in which direction?
Right.
To the right. Why right? So see this hump right up here where it starts at 0, 1? We're going to move it 1/4. Well, here's 1/4 right here. So we are going to take that, and we're just going to shift it that way, pi force. Got it? I shifted over pi force, and then we can add to it right here. So it's all the way to that.
So we made it a sine.
There it is. It looks like a sine function because it goes through 0, 0, right? Okay, but we've made that shift. So now we are going to take the part of the graph. We just graphed some functions where we had y equals a sine or cosine of k theta minus c. Now we're going to add to it the h. What does h do to it? Okay, it shifts it up or down. So if I had something like y equals cosine x plus 2. Is that a vertical or a horizontal shift? It's a vertical because the plus 2 is not included. We're not taking the cosine of that. We're just taking cosine of x, and then we're adding 2 to the whole function. It's going to make it all move up 2 units. So we're going to do an example and graph one. Let's take, for example, this one right here. Y equals 2 cosine of theta minus 5. Y equals 2 cosine theta minus 5. What two things do we have affecting the graph right here? Amplitude and vertical shift, right? So it's going to move down 5. Now, we're going to on this one right now, I'm going to make every line right here 1. So this 1, 2, 3, 4, 5. So this is -5 right here. Okay. Now, when we do this, when we do a vertical shift, we are going to have this thing called the midline. The midline takes the place of the x-axis. It's our new equilibrium line. In other words, the sine and cosine functions are going to oscillate back and forth over this midline instead of over the x-axis. And then my amplitude is 2. My amplitude is 2. So that means my graph is going to go up to what number? -3. That's exactly right. And so I'm going to put a dotted line at -3. And what's it going to go down to? -7. Because remember up here, if we were up around the x-axis, it would go up to 2 and down to -2. But we shifted everything down 5 units, right? So it's going to go 2 units above -5, which is -3. So right here is -3. And it's going to go 2 units down from -5, which is -7. So my graph is going to oscillate back and forth between -3 and -7. And -5 will be that equilibrium point. And so we are going to graph this function. Has amplitude to 2. We know that a cosine function starts off at 0, whatever the amplitude is, right? But in this case, it's going to start at 0, -3 because that's the high point on it. And I got to mark pi on here. 1, 2, 3, 4. That's pi well, we were going every 2 units, right? So I'm going to go, that's pi right there. 1, 2, 3, 4, that's 3 pi halves. 1, 2, 3, 4 is going to be 2 pi out here. So my graph is going to look like this. Okay? So it's going to come this way on this side. Whoops. I am not doing well right here. There it goes, like that. It's going to look like that. So it's moved down 5 units. Any questions on that? Can I get that idea? Okay, so on page 380, it gives you 4 steps that we're going to use to make this graph. You can look on page 380 and get it out of your book. Basically, we're going to find the midline. We're going to find the amplitude and put some dashed lines. We're going to find the period. We're going to graph it, and then we're going to do the shift at last. Okay, so we're going to take this equation right here. Y equals 4 cosine.
Are we doing this on this paper?
You're going to use that piece of graph paper I gave you. Theta over 2 plus pi minus 6. I suggest on your graph paper, the first thing we have to do, following those steps, was to find the vertical shift. How much is the vertical shift? -6. So we're going to go down to -6. So 1, 2, 3, 4, 5, 6 right here. And we are going to, I'm going to use this black one right here, marker. We're going to put the midline right here at -6. -6 is our new x-axis, in other words. So count down 6 on your graph, now that we've got them all going. And that right there is your new midline. That's step 1. Okay, what's step 2? Okay, amplitude. So the amplitude's what? 4. So we're going to go up 4 from the midline. 1, 2, 3, 4, and we're going to put dotted lines on the midline. We're going to move this thing up right now for a second. And down 1, 2, 3, 4, and here's our midline, our other dotted line, which is our boundary for our amplitude, how far up and down we're going to go. Okay, what's step 3? Period. What is the period? How do I determine it? Period equals what? Okay, what is K? What is it? It's 1/2. Everybody look right here. Theta divided by 2. I had some kids in my last class say, isn't K 2? But they knew it was on the bottom, so they thought there's something fishy about it. That's just saying 1/2 times theta. So, yeah, so we have 2 pi divided by 1/2. Well, we got to take the reciprocal of 1/2 and multiply it by 2 pi. So the reciprocal of 1/2 is 2. 2 pi times 2 is 4 pi. So our period is 4 pi. That means I've got to go clear to 4 pi. Now I'm going to change, right now you guys, we're going to change from what we've been using the scale at. Every mark is going to be pi fourths. So there's pi right there. On your paper, I'd suggest doing the same thing. There's 2 pi right there. There's 3 pi. And there is 4 pi right there. Okay, so mark your graph accordingly. Hey, how are you doing? You bet. Come and watch. Now, we have our midline. We have our amplitude dashed lines. We have the period is 4 pi. Okay, so we have to have one whole cycle has to take place between 0 and 4 pi. So we're going to graph the function, though, without the phase shift. So we're going to do that in green, or red, right here, since I have red. So where would I start from, you guys? Where would I start this graph from? What point? It's a cosine function. Forget about the phase shift right now. Where would I start it from? If I would I start it at -2? Why are you saying -2? Oh, yeah, -2. I forgot we'd shifted it down. Okay. We're going to start at -2 right here because we know that the cosine function is going to start at 0, whatever the amplitude is, right? And we go up from our midline 4 units. And we have to have one whole cycle take place between 0 and 4 pi. So we're going to start right there. We're going to go down through pi, bottom out at 2 pi, come up through 3 pi, and end right up here at 4 pi. And just so we have a consistent graph, we're going to do this right here. I'm going to duplicate this. I'm going to clone it. I'm going to make another one right here. And we are going to move this one over here. And there is the function 4 cosine of theta over 2 minus 6 without the phase shift. Okay, so now we have to get our final graph, we need to find the phase shift. What is the phase shift right here? -2 pi. How do we figure the phase shift? So negative pi over 1/2 c over k. And what does that give us? We simplify it. I think you said it. -2 pi, right? So I have to shift this thing. How far in which direction? How far do I have to shift it? To the left 2 pi. So let's start right here where we started the cosine function at, and that's right here at 0. I'm going to have to shift it all the way over to -2 pi. So that hump has to be right here, right? Okay, so we're going to do that in blue. Right here. If I started that right there, that means this thing's going to come down here. I'm going to start right here. I'm going to go up. So that hump right here is at 2 pi. Cross down through pi. Bottom out at 0. Cross through pi. Up to 2 pi. Down here. And we have the graph of y equals 4 cosine of theta over 2 plus pi minus 6. We shifted it to the left, that -2 pi. Okay, so that's basically it. Okay, I want you to use that graph paper to do your assignment. So you have nice, tidy graphs. And I want you to make sure you're nice and tidy like we did on this one, right here. And on any of the graphs. There's about 4 or 5 problems on your assignment that are going to require you to graph on it. Maybe 6 problems, okay? I'm going to give you 2 class periods to do this, so this will be due again next Wednesday. And we will work a little bit on this in class on Monday, okay? Here is your assignment, right? There's your assignment.